Hey everybody, my name is Katie Thomas. I'm the marketing manager for the School of Data Science here at UNC Charlotte. I'd like to welcome you all to the fourth annual Charlotte Women in Data Science virtual conference hosted and sponsored by UNC Charlotte's School of Data Science and Lowe's. The WID Charlotte Conference Initiative aims to inspire and educate data science across the region, data scientists, across the region, regardless of gender, and to support women in the field. With the current state of the world mainly interacting online, we are grateful for your decision to attend our two-day virtual event and show your support for our various speakers. I'd like to extend a special thanks at this time for all of our attendees for showing up, connecting, and showing your support for all of our amazing speakers from across the region. And with that, I'm extremely excited to introduce our speaker for the hour, Jamie Stagel, and her presentation, Business Translation as a Building Block for Career Success. Jamie is currently serves as a data analytics lead with the Analytics Center of Excellence for Corning Optical Communications. Jamie, I'll let you take it from here.
Thank you, Katie. I can teach a mathematician the economic labels easier than I can teach an economist the math. Good afternoon, everyone. Like Katie said, my name is Jamie Stengel, and I'm a data analytics lead at Corning Incorporated in our Optical Communications division here at Charlotte. And that quote that I opened with, I chose for a reason. It's something that my mathematics professor told me when he was trying to convince me to switch from being an econ major to a math major. And I think at the time it was to no avail because I stayed an econ major. But now that I've been working a few years, I realized the larger point he was trying to make, and I see its relevance for data science as well, which drove me to apply to speak today and write this presentation. While there are many definitions of data science, most would agree that it is definitely an interdisciplinary field, often combining tools from math, statistics, and the area of computer coding or computer science. And that quote I opened with and the idea it conveys is that it's often easier to teach someone grounded in the field of data science, the labels that they need to apply to different use cases, than it could be to teach someone who's not had any exposure to it but is a business expert in their field, how to apply the data science techniques. And I think that's why we have so many data science practitioners across industry, as you've seen from the opening speakers this morning and with the amazing panelists across the 2 days today and tomorrow. We have people, whether they're in finance, public health, or economics. Data science really can be applied anywhere. It's just a matter of how we label the problems. And so that leads me to my presentation today, Business Translation as a Building Block for Career Success. We cannot overlook the need to learn and understand the labels of the fields we are in when applying data science to our respective industries, because it is this teaching of the appropriate labels which will help get buy-in from our business partners and ultimately turn our data science provided insights that we give them into action or decisions. So with that, today I will be covering 4 key points. The first will be the transition from academia to industry. The second will be the idea of what a data translator is, followed by a case study based on my own experiences, and then wrapping up with the continual journey toward actionable data insights. So now that we've taken that intro, let's kick things off with a look at the move from academia to industry. When I was in school, I was first exposed to data science through my master's program. And I think a lot of college programs do a couple things really well in this field. You know, one, they're helping you when you're like me and have never been exposed to it, get grounded in the foundations. And what this often means, as you can see on the slide, is you get a nice predefined application and a clean data set typically. In my master's program, which was a finance focus, I was in a quantitative finance with Python course, and the focus was on how do we apply these trading strategies that asset managers and hedge funds use to the data science realm. And specifically, we would look at really finance-focused applications, right? And so that was the predefined application. It was how do you build the FAMA French 3-factor model, or how do you build a momentum model to help determine how many long positions to have in your portfolio. So it's really narrowly defined. And again, I want to highlight this actually is not a weakness of academia. I think it's necessary. My first day in that class, I was definitely overwhelmed by all the data science terminology and the coding language as well. But it set me on the path to where I am today. And so there's a lot to be had from getting a foundation in data science when you're in school, if that's possible for you. So the next step, though, is to go from your college or master's experience to industry, right? We inevitably have to go take what we learned and go out in the world and apply it. And so for me, this occurred just about 3 years ago now, when I finished my master's degree and started at Corning Incorporated. And for a little bit of background, in case you don't know the company, as I didn't until I applied there, they actually make a variety of products you might interact with on a day-to-day basis, but be unaware of. For example, the glass on your smartphones, the optical fiber, which enables us to connect virtually over this conference platform, and even the glass behind COVID vaccines are all made in part by Corning, among other companies as well, but those are the spaces we play in. And so I had known that when I went in, but I knew that I was not going to be in operations, right? When I look at the company as I was starting and going in this transition, I knew, okay, in a manufacturing plant, such as the one pictured here, there are some clear data science use cases, one of which could be to detect product defects, right? A lot of the products they make are more or less glass of various types, whether it's the glass again for your iPhone or other smartphone, or the glass for a vaccine vial. And so one clear-cut definition of data science that could have been applied in an engineering role would be, how do we use image data to detect defects in our glass, or any scratches, or is it too thin or too thick? My task, however, was to go to finance and help support the function so that they could make strategic decisions and analysis based on the insight I was set to provide. So, you know, it's worth mentioning because I want to point out for those of you listening that might be in school still or are new in your career, it's okay if you don't know right away the application you're going to have, you know, and sometimes you will. Again, if you are sent to a plant, that's going to predefine the areas of data science that you're going to be playing in, versus if you're in a finance or a functional role, maybe commercials like sales or something of that nature. A few other examples I have listed here, though, include fraud detection. If you go into banking, some have specific units for detecting fraud, and that's a clear-cut application. And then also inventory optimization. Supply chain is really rich in data science, I think, at a lot of big companies. So these are some cases you might use, but you might also be a little lost. And so if you are, that leads me to my next point, which is the idea of a data translator. So like I mentioned, my background is really finance and not officially data science, but I was in a program where we were exposed to it. So the example I'm going to start with, though, came from these bankers that would come to help train us on how to do discounted cash flow valuations, which basically is a fancy way of saying how they arrived at their stock price predictions for a given company or the valuation of a company. And these investment bankers would often come in and say, you know, I'm going to teach you all this stuff, but really this is more of an art, not a science. And it sounds silly because on the one hand, there was a scientific process to what they were doing, right? You have your projections of cash flows that the company's going to produce so many years in the future, and you have to discount that back to the present. And there's not really much art to it, or so it seems, right? But the art that they kept talking about comes in the underlying assumptions for those inputs to their discounted cash flow model, right? You might think, well, how do we determine what that discount rate is? Does the company have a lot of debt on their balance sheet to fund new developments? And does that mean that cash flows they might make in the future won't go to shareholders, but rather to pay off their debt, just like we have to pay off our debt as individuals on credit cards and other places? And so I really thought it was a cheesy saying, but I bought into it as I learned more and more about finance. And now that my job has taken me more into data science, I think the same thing applies. And so it's kind of funny because, of course, the name of the field is data science, but there is a lot of art, and the art comes in knowing which tools to apply in which cases, much like those bankers had to know how they needed to set the terms of the model. And so the fundamental task, as I put it here, though, is, you know, how do you put a lot of statistical phenomena into business terms? And one example that I like, for those of you that have had this experience or are big math fans, right, there's oftentimes in natural phenomena second order effects. And these can have specific business labels. if I was in college still and talking to my math professor who tried to convince me to be a math major, right, we would just use the word derivative, right? Okay, well, what's the derivative effect going on here? But believe it or not, in business, a lot of people are scared of math terms. So I would end up having to think about how can I phrase this to put it into a language that they'll understand. And so something that business people often understand intuitively is diminishing marginal returns. And this is, again, a second order effect, basically, the derivative, and how is the slope changing and is it getting smaller over time? So the idea of a data translator is to do just that. You have to be able to know from the art part of the data science process, how am I going to put this statistical or mathematical output into something my business partner can understand? And I think another good example of this idea comes from, of course, foreign languages. And for those of you that either speak a foreign language or know a little bit of it, you've probably traveled somewhere and been lost and had to think about, how do I really say something in another language? And for me, I speak German, and I know that there are some things that do not translate word for word from English to German and vice versa. And this often happens with idioms or phrases such as those. And one of my favorite ones in German is Ich verstehe nur Bahnhof, which when you literally translate it into English means I only understand train station. And that doesn't make any sense. But what it actually means is the same as our English phrase, it's all Greek to me, like I don't understand. And so this idea of a data translator comes naturally to me because you don't want to deliver something to your business partners and have them just say, this is all Greek to me, I don't get it at all. I mean, it's something I still have to work with. I was talking about coefficients of variation, and that's something that comes very natural to me, but my business partners didn't get it. So I had to really think about, how do I bring this down to a tangible example that they will understand? And I think, the beauty of this is that you will learn more as you go through, and this is something I'm going to speak to next in the case study, but you'll learn how to iterate through this data translation process and really get good at it. And so a few other things that I just want to highlight here is when you're going to translate your data, so to speak, you also want to be aware of the structure of your data. For those of you who have been, practitioners in data science for a while, you probably know this. This is something I really learned quickly going from school to working, but thinking about what is it I need to do with my data, right? And how does it need to be shaped? I'm sure many of you have heard about like tidy data from Hadley Wickham with the R library, but it goes even beyond that. You need to think about when do I need to have my data be pivoted or unpivoted, right? To do certain mathematical operations where I need my variables in the columns to do, again, percentages of another column, or do I need them to be rows instead? And so all of that is encapsulated in this idea of data translation. And it's, again, pivotal that you have that basic knowledge so you can then present that to your business partners. And so before I go into the case study, I just want to take a second and really wrap this up with one other example that I will be speaking to. And so if you have, a gamma distribution, which might not mean anything to your business partner, you're not going to go up to them and say, oh yeah, I use this gamma distribution. That literally would be their, I only understand train station moment to you, right? That's probably what they would say. But if you instead say, I use a distribution that has our predictions bounded above 0 because we're predicting revenue, and that's a non-negative number, they will be on board with that. So it's really, when you're trying to get buy-in, I just think you need to put it so that they're comfortable, because unless your company is a digitally native company like a Google or Amazon, this is new for a lot of companies to be pushing into data science, and you want to make everyone comfortable and on board with your goal. So now that we've set the stage of the idea of data translation, I'm going to go through a case study of how to apply it to make it more concrete, hopefully for all of you. So all businesses, no matter what industry, need a steady stream of revenue if they're going to stay in business over the long term. And so it's no surprise that revenue forecasting often gets a lot of attention as a quick, a lot of people think it's an easy thing to try data science methods on. And so in addition, many companies will have a handful of key customers that derive the majority of their revenue, similar to Pareto distribution in the 80-20 rule you often hear about. Maybe 80% of the company's revenues come from 20% of the customers. And so at my company, we have a similar case where we have a handful of key customers that are A, more volatile than the rest of our customers, and B, that we derive a lot of revenue from. And so this leads to the first part of my case study. And as I go through this, I'm going to try and highlight the different parts of the data translation and business translator role. And the first part is to ask, what is the business problem? And more fundamentally, what is the goal that they're trying to achieve through this business problem? And so in this case, the goal was to forecast revenue. And specifically, they came to me and my team and they said, we want to be able to see around corners and anticipate potentially large changes in revenue from these key customers. And that's very broad, right? So if you are a data scientist and you're told that, it might not be clear at first what the data science question is there, right? So this is the first step in business translation, going from the business problem, once you've established it, and putting it into a data science question so that you can leverage all your data science tools to answer it. So when I heard that question, or rather the business problem, and I was thinking about, well, what data science question does it associate with? A few things came to mind. One was that phrase, see around corners, kept jumping out to me. And I thought, it sounds like they're trying to find leading indicators. And when I think about the problem that way, my mind goes to cross-correlation analysis and how can we find things that are correlated at a time before time t equals 0. And so that is one part of this translation step, going from the business problem to the data science question. But in their business problem, there was actually a second data science question directly related to the first one I just mentioned that was perhaps more important. And that is, would any of these highly cross-correlated external variables with our revenue be predictive in a modeling and forecasting example? And so that was one, that I'll again get to, but that was the second nuanced question. So I'm just trying to give an example of you're given a business problem, put it into your data science questions, and then you can move on to the next step. That is to utilize your available tools in your data science toolkit. So here you can see, again, I clarify what I just spoke to, that seeing around corners aligns with the data science question, are there leading indicators? And at this point, you can, like I said, use any of the tools you have available. I focused at this stage predominantly on cross-correlation and distribution analysis in R and Python. Depending for me on what I'm trying to do, I will use both languages. Some have, like R has better packages for some analysis, and Python, I love their pandas library. So at this stage, for example, I leveraged pandas in Python to do a heat map and at scale, quickly analyze a variety of cross correlations to see if any of these external variables we looked at for our key customers were in fact correlated for the current time period with our own revenue. And so an example output I might show to the business partners is the visual you see here. It's showing, at time period 4 periods prior, P minus 4, the correlation was over 80% for this particular example, right? With our revenue and this external regressor from a key customer. And again, I'm keeping this anonymous, but hopefully you get the point that the visual is trying to make. And so these cross-correlation analyses were just the start. Once you've utilized your available tools, you still have more work to do. And for me, that moved into the modeling space. And so when I start with this approach in any problem, not just this case study, I always try and start with the simplest model. And that's the bullet I have here on the slide is you want to try and engender that trust with your business partner. In particular, my group, we're a new group, like our Analytics Center of Excellence at the company. So, there's always some people skeptical that they might say, well, I just trusted my gut instinct before, and I don't know if I need to, worry about what your model says. So start with something simple. And in my case, that was a linear regression model. And then as the approach becomes more complicated, keep open what I call vectors of understanding. So I'm going to walk through this example. So I started with a simple linear model, and one variable was not enough, but then I had to add a quadratic term. And I spoke about this earlier because this was the example I was thinking of most recently, but that quadratic term in this example was getting at diminishing marginal returns. And so as you go through your data science toolkit, the reason I have this title, Can My Business Partner Understand, is this is a question you want to constantly ask as you're iterating through your data science process. If you get to a point in the model, like you see here, again, an anonymous model, but if we're predicting revenue from customer X and we have these external regressors and one of them is a squared term, how can you explain to them that that's modeling diminishing marginal returns? And for this, it was an intuitive example because I could say, think about revenue. If you're starting with a base of $100 million, a $1 increase in revenue is going to have a bigger impact than if your base is $1 billion. So that my business partners understood without a problem. And it was much better than saying quadratic term. However, this is just one question you need to be asking yourself. The other is, do I understand the business implications of my findings? And that's why I brought up the foreign language translation example earlier, because you kind of always have to be thinking in both languages, so to speak. It's not just, can my business partner understand the data science output I'm bringing and how do I tailor that for them? But do I understand, as I go through my data science approach, what the business implications are? And so if your data science inquiry leads to more advanced methods, make sure you know all of those implications of your model parameters and assumptions. And that's what I'm going to speak to now with my case study. I just put here, though, briefly to speak on the technical side of things. I heavily utilize the stats models package in Python. It's got a lot of great, robust modeling techniques for those of you in the space. And then we use Databricks, which is cloud-based, to help automate the running of the model then once I was done. And it's great because with Databricks, we can track experiment IDs. So like as time goes on, I don't have to overwrite, or rerun my code and overwrite the old output. I can just keep track of, okay, when we only had predictions through the end of Q4 2020, the model said this, but one extra data point, how did that change the prediction? So from a technical side, those are the tools that were used. But now going back to the business translation piece, in this case, I couldn't stay in the realm of linear regression because it did sometimes allow for negative predictions. And like I said, we're predicting revenue, and that has to be a positive or non-negative at least number. You don't want to have negative sales. So that's where I went into the realm of generalized linear models, or GLMs, as I will refer to them in the rest of this presentation, to align with our business. And so here, this took a lot of thought, right? I mentioned I have a background, where I have used advanced modeling techniques, but I had to think about what is it about these GLM models that helps me in this case. And here it came from a few things. One, in a GLM model, you can specify your output distribution, and that in this case was a gamma distribution, which I explained to our leadership team as being beneficial because it bounded predictions above 0 when we forecasted out of sample. The other beauty of GLMs that I found and really liked in this use case was that we were able to use a log link function to allow for nonlinearities. So again, that was probably maybe a little high level, and I'll break it down into how I spoke to both leadership and then those involved in the day-to-day operations of the business. So those two words, gamma distribution, log link function, probably meant nothing to my business partners that were leadership level. So when I broke it down to them, I purely would explain that I use this GLM approach because it bounded our revenue predictions above 0, and it accounts for nonlinearities in the relationships between the external regressors we found to be predictive and our revenue from that customer. So I think that's high level enough that they'll get it and see it, but you don't have to go into the details. And that's, again, that business translation role, and you're getting leadership buy-in. If, however, my audience was, and this happened in some cases, a level down and were more involved in the day-to-day operations, or maybe they were the sales organization members that worked with the customers whose revenue we were trying to predict, I offered more detail. And that might have been something like, a GLM model is still a linear combination of external regressors that affect the prediction. The difference between that and a linear regression model is the external regressors can be transformed to account for nonlinearities. And this transformation occurs through what's called the link function. And in this case, I used a log link function. And then the other benefit of this model is that the output distribution can be changed like I did with the gamma distribution. So that the final definition I would share with these more operations-based practitioners would be GLMs are just a linear model for a log transformation of the expected response, right? Our Y that we're trying to predict. And another thing to be aware of when you're doing especially advanced modeling like this that you have to convey is it doesn't hurt to have some backup slides in an appendix form where you show, especially for a small example set of the data. You don't have to do everything manually, but I did that in this case where I proved out what my code and all the more advanced things at scale, right? Because we have customers with that do produce a lot of revenue for us, and we had a lot of rows of data, so it was fairly large. I wasn't going to do it for everything, but I was able to show them what the impact of this modeling technique was, and they were really appreciative. Again, only the sales folks ask for that. Leadership usually won't, but it's good to have in case people question it, because again, you want to get that buy-in from leadership so that they trust your model. So next, we're going to focus too on how do I best present to leadership. And oftentimes you have a short window to make an impression on leadership with your findings, and you want to guide them to key takeaways with the headers on your visual. So for example, in this deck I'm sharing with you all today, I've tried to put the questions that are part of my business translator process as the title, because that's what I want to leave you with. But in the case study I've been walking you through, a lot of the titles might have just been something like model approach predicts upside relative to internal view. You know, something that they can quickly see, okay, this analytics-based approach, this data science-based approach differs from the internal bottoms-up approach. And a lot of companies have, when I say bottoms-up, you know, they have their sales folks and others that are in the business putting together projections based on their knowledge. And so with a header like that, you really get their attention because one of two things will happen. One, they'll be surprised that it's different, or maybe two, they'll be glad to know it's different and that maybe it's a point of further analysis. You know, what is driving the divergence? And I think that's important too. I'm talking about it on this slide, but it's beyond just presenting to leadership. But I think for anyone in a data science role, being aware that you don't have to worry about if your output is different than what people have traditionally expected. You know, my econ professor would always tell me, you know, don't try and force your data to tell you what you think they should. You want the data to tell you what it's trying to tell you. And that might be different than people's intuition because you're using new techniques that are uncovering under other relationships in the data. And so I wanted to make that point too, because it's really key. And then also on this point, when you're presenting to leadership, you have to be aware of the visualization of your validation techniques. I'm not going to go into it in too much detail, again, because this is more of a career development session than a technical one, but think about how do you show visually and get the takeaway of train test split performance, cross-validation performance, retrocasting, and how can you make that intuitive? In another instance that I know we've used a lot in my team, business executives love mean absolute percentage error, or MAPE, and sometimes you might want to use something like RMSE that is maybe more intuitive for your data set. So just keep those in mind too when you present to leadership. And with that, I'm now going to turn towards the final point and wrapping up. That way we'll have plenty of time for questions. And that is this idea that the journey toward actionable data insights is on. And that's why I love this picture I found, but the journey is always on. Like the opening panelist said, this is a really exciting industry to be in. It's an incredibly exciting field to be in as well. And I'm going to recall the 5 main building blocks that I view as the business translation building blocks for career success, and then I'll wrap up. But the first one was, again, what's the business goal? And then you have to ask, what tools can I utilize to achieve that goal? So that's that first part of the translation. And then kind of while you're working in whatever language you want to think about, and that also speaks to your coding languages or your tools for visualization like Power BI or Tableau, ask yourself, can my business partner understand this output? And do I understand the business implications of my findings? And here I think it's important. If you don't, that's okay. Like I mentioned, I've only been in my company for 3 years, and I work with people who have many more years of experience. So find a peer. You know, if you're doing a capacity optimization project and you don't understand the business implications of your findings, maybe talk to someone in supply chain and see what they think. And then finally, we covered some techniques on how to best present to leadership and make sure that all of your findings are clear and concise and get them thinking so that they can take action. So this whole process is an iterative process. I think we hear that a lot about data science, and I think it applies equally as well to the sharing of your data science output. You have to learn more and think about new ways to share this. As I was putting together this presentation, these building blocks came because it's really what I must go through each time. And I don't always succeed. Like I said, I just the other day had some issues conveying to people why we needed this coefficient of variation. And someone had left saying, oh, well, I felt like I was just in a master's statistics course. And so I thought that means I didn't do my job as well as I wanted to, right? So the goal should be no one should leave your presentations confused. And if you go through this process, you will get there and your journey will stay on. So with that, I will open it up for questions and welcome any.
So how do you, you talked a lot about interpreting your models being able to, you want them to, your business partners to be able to interpret business insights from your models. And I kind of wanted you to talk about how do you feel about models that maybe someone who doesn't have the most analytical background or business knowledge, like, in the general public, to be able to interact with models and understand business insights from them, or not even just business, just overall interpreting models?
Right, so that's a great question, and I'm trying to think of a good example, but maybe one just because it's part of our lives. I think this whole COVID experience might be a good example to think about when it first started, and there was a lot of epidemiologists trying to convey to those of us. I'm not an epidemiologist, right? But so they were using on the back end a lot of data science techniques to model how the virus might change. And I know we're in a very different state now, but I'm sure a lot of you remember about a year ago when things first started closing, right? They talked about the flattening of the curve, so to speak. And so I think that was a good example of how to make it intuitive, because again, in the back end, there's a lot more going on. But if you can come up even with a one phrase takeaway of what your model is saying, or what the goal of your, and again, in their case, they needed, right? They were trying to get people to take action to help flatten the curve. So I think if you compare not only a simple model, whether again, like you said, it's in just the public day-to-day life or in a business case, if you can also say, this is the action you need to take based on this model, that's really powerful. And so for us, then, like in that case study I spoke about, and again, just high level about it due to anonymous purposes, but we wanted the takeaway action to be, investigate this, or that there might be up or downside coming. So like we put that on our takeaway slide because we didn't want people to just say, oh, that's interesting. They're seeing more upside or less than what we are. It's like, no, because right, if you're in a company that has a manufacturing footprint like Corning does, they have to be able to plan if there is really potential upside in revenue, that means the demand's going to be coming, and how do we do that in the manufacturing space? So I don't know if that answered your question, but hopefully a little bit.
It did. Thank you.
Okay, great. Are there any other questions? To the idea, I guess I'll ask one maybe to you, Mia, and then if anyone in the audience wants to answer, has anyone gone through, or did this idea of business translation make intuitive sense? Did it seem logical? Or
for me, yes, it did, definitely, because like you said, like in being able to interpret the insights is everything. Like you can look at data all you want, but there's really no value from it if you can't interpret it and apply it. And so I thought that was logical.
And that's good that you say that, because again, if this fell under the career development piece, and I just want everyone that is listening, no matter what stage in your career you're at, I think that's the ultimate takeaway too, because I've seen people, like friends of mine, when they worry about going into an interview for a data science role, well, maybe I don't know all the latest tools, right? Like you can always learn that. I mean, I'm sure all of you know about Stack Overflow. I love that for coding questions myself, but you can always find ways to, use new techniques, but you can't always teach people to have that natural like inquisitiveness of, okay, like how do I make this relevant and actionable?
Looks like someone in the chat said, yes, I get the same experiences every day when I try to explain any insight or number
Yes.
to my leadership team.
Yes. And I'll say too, maybe just if people are commenting that too, don't get discouraged. I will say, depending on where your company is in their data science journey stage, that's why I said the journey's on, like you're always on it, because I remember thinking, oh, we're in this new formed Analytics Center of Excellence group. People will automatically want to, buy in and take action, but we still have team meetings where we focus on, are people acting on our insight? And if not, why? Because like I said, there's just going to be some natural resistance, right? When there's anything new. I think one of the panelists on the group of women that spoke this morning mentioned, it's kind of change management too, right? In finance, for example, I think a lot of people are used to more traditional accounting type roles, a lot of reconciliation, and they might be intimidated by data science techniques that they think might take their job in the future. But it's not about that, right? It's if you can free up people's time to focus, then they have space to analyze other impacts and results. So, and for those of you, I think and Mia, jump in if I'm incorrect, but if you found the questions I have as the building blocks useful, that presentation should be in the app as well.
Yes, it's there.
Great. Oh, I think I have one potential question. Oh, thank you. But yeah, thank you all for listening. Wish I could see you all a little bit more like when things were in person, but I look forward to doing that soon.
We actually do have a question under that. If your business model is transactional, how do you manage data when it gets too big, like moving from relational to other?
Okay, so if I'm understanding this question right, you mean maybe like database management too, like the back end data that's feeding all of your models? Yeah. Okay, so then I have one about how big is our team in Corning. Okay, so I'll kind of answer these. So the first one, I would say, and this is where, so I'm not, a software engineer, but if I'm reading your question right on the data, we have tried to do a few things. One is utilize tools where we really can like connect directly to databases instead of having maybe transactional data stored offline. So we're moving a lot towards cloud-based solutions for our larger data sets. Hopefully that answers your question. Yes, and like when you mentioned Power BI and Tableau, that's exactly, I use Power BI every day in my job. Some people in my company use Tableau, the division I'm in uses Power BI. And so that helps a lot, but even then I'm trying to get to the next step and really just connect directly to say SAP or other sources in Power BI. And it's so much faster. And then to Flora's question, our data science team, it's actually interesting. So my immediate team in the optical division is right now just 3 people, but we're kind of all spread out. We have these analytics center of excellence in each of our 5 divisions. So I mentioned how we make in mine the optical fiber that again is, on the backbone of this Zoom webinar, right, enables people to connect via 5G technology, things like that. That's our space. We have a life sciences division. They have their own analytics center of excellence team, but we're all kind of in the division level. I say there's a much larger data science presence actually in manufacturing. And so we would have these data science, we call them rodeos, but places to share knowledge across functions. And that's how I learned a lot about the supply chain and manufacturing use of image techniques when they use data science. But in the businesses, I would say it's probably about like 5 to 10 people per business unit. So probably about 25 to 30 people. And we have like a director of data science too.
We have another question in the Hoover chat from Elham. They say, hi, Jamie, thanks for the great presentation. How do you connect the business requirements with the business goal?
Okay, business requirements. So I'm going to think about how I'm interpreting what you mean with that, but I would say, like in the case study I brought up, this business goal and problem kind of came to us based on the need that like we just had in our business. They said we have to get better at this. We really do have a few key customers, and our business, the financial side, which was my original background, we saw the impact, right? It was affecting our gross margin. It was affecting our fixed costs, right? Because like I mentioned, if you can't tell in advance that a customer is going to be putting in more demand and wanting to buy more from you, you might not be able to capitalize on that demand at all if you don't have the capacity, right? So if I'm interpreting like your view of business requirements, that's really what drove ours. Is there was a need at the bottom line profit level, right? Because revenue in a financial statement, revenue is at the top, right? That's kind of what drives everything, and it all flows after that. But we were seeing impacts on our gross margin, profit, final NPAT, net profit after tax, and then in the plants too, you know, were we in demand management or not? And so those are the requirements oftentimes that will initiate these like data science questions, right? Because I will just say too, be careful when you're in this, like people, I think, want data science to be a silver bullet in a lot of businesses, in the sense that they think, oh, like now we have this, you know, analytics center of excellence team that does data science, like let's just give them this problem and they'll solve it right away. And you saw the questions about big data models and stuff. You know, a lot of times the data issue can affect how soon you can act on that. And then also maybe if you thought of business requirements this way, we also had to go be able to push back, you know, in a nice way, but say, you know, we can answer these questions, but we need your help from the business to get the data that we need, right? Because if you have these analytics center of excellence models in your organization, you might not have the native access to getting the data that you need. So you might have to talk to the commercial group or the supply chain team to get that. But I would say, you know, there's usually a key business driver that leads to these questions, and then just making sure that too on your business translation journey, because you want it to help make your career successful, right? And I've had the opportunity to present to leadership. You want to make sure that they realize it's not a silver bullet, and you want to get kind of people out of the, I'll call it the buzzword view of data science, and really seeing, no, it's just, you know, a really in-depth view of tools, honestly, that have been around oftentimes in many cases for a while, but now we have other things that augment them and again, lead to this interdisciplinary data science field. Any final questions?
I think that's all we have for now.
Okay.
But thank you so much, everyone, for coming. And thank you, Jamie, for speaking with us today.
Thank you. I hope it at least was interesting and hopefully useful to some of you. And again, feel free to look at the PowerPoint and the app. And thank you all for attending. And thank you, Mia, for helping moderate. And tell Katie thank you. And thank you. We'll have a good one, everyone. I'll hopefully see you all at a later session.